Hi, my name is Kyle Hammer, and I'm going to be talking about the extra behaviors I added to the finite state machine. I made this project for its utility purposes. I do actually plan on working in Unreal a bit after this semester finishes, and finite state machines is what I've always kind of used for my enemies. And I plan on just using this finite state machine, improving it, and working upon it in order to use it for my future projects, which I'll be doing in Unreal, like Crystal Make number 2. So before we go on and start looking at new behaviors, let's look at our existing behaviors. We have this patrol state, which is also the start state, where the enemy walks around a node-based system, just finding random nodes, walking towards them, keeping an eye out for the player. If they do happen to see the player and they're over 40% HP or equal to it, they're going to start firing towards the player while also walking to the nearest node. Once they get to that node, they will turn around to face the player and rotate towards them while firing their gun. If they lose sight of the player, they will go back to the patrol state. If either in the patrol or engage state they happen to go below 40% HP, they're going to instead evade. Now, evade normally has a fire function to it where the enemy fires while also running away. I just removed it so it better reflects the fleeing behavior because of the extra behaviors I'll be adding to this project. So instead, evade will just have the enemy run away from the player. So let's talk new behaviors then. I think one of the essential ones would be death, just so we can actually kill the enemy. A startled state would be quite nice if we get the jump on the enemy without them noticing us. Chase state, where they chase after the player's last known location. And an investigate state, where once reaching that last known location, if they still can't see the player, maybe just have a look around to see if they're still around. There's also some utility states here, but I won't cover those just yet because I actually developed those a bit later, and I'll cover why as well. So yeah, let's move on. So here we've got all of our new states on the left-hand side, but how are we going to implement it into here? Well, let's start off with the easiest one, death. Bam, easy. No matter what state the enemy is in, we want them to die when their health is under or equal to 0. So yeah, any state, if it happens to occur, then just kill them. In order to have it go from any state, we have this constantly running in the update loop to check their HP. And once the HP is below 0, enters that state. The next state would be startled. Startled is also transitioned from any state, similar to death. Now, you could make an argument that startled can only recur from patrol, and you'd probably be right, but since we're going to be extending this finite state machine a fair bit, we want it to be startled from more than just the patrol state. So for now, I've got it linked up to the any state. If they happen to take damage and the player hasn't been seen, then switch to the startled state. I reflect this in the project by having the enemy jump up and turn around in a panicked sort of spin just to try and look for the player. Now, let's take a look at the chase state. So if after engaging, you can no longer see the player, we're going to have the enemy chase after the last known location. I'm also going to sever one of the ties to patrol for engage. So instead of cannot see player going to patrol, it's going to go to the chase state. Investigate state is the next one. After the chase state occurs, he's going to go to the destination that the player was last seen at, and the investigate state will feature the enemy going around in a circle trying to look for the player. Now, we need a way for the chase state to switch back to engage in the case that they can see the player. But there's a bit of a problem with what we've currently got here. And I'll show you in the next slide. Engage state currently fires while finding the nearest node. And why might this be a problem? Well, it's because the chase state kind of takes the enemy off the node-based system, meaning that they can follow the player to the end of the earth, but when it comes to firing at the player, they need to go to the nearest node and then start firing at them. So what this will do is, it'll have the enemy run looking at the player, then turn around to the node to walk back to it, then look back at the player, back to the node, back to the player, back to the node, and they kind of get stuck in a loop. So how do I remedy this? I create a new state, engage pivot, one of the utility behaviors I was talking about before, something that I didn't initially plan at the start, but ended up developing later on. So instead of going back to the engage state, it goes to this engage pivot state, which is the same as engage, except doesn't run back to the node. Instead, he just stands in place pivots on his axis and just shoots towards the player. And if he happens to lose sight of the player, he's going to try and move to the last known location through the chase state. Investigate state also needs a way to start firing towards the player. Again, we can't link it up to engage, because what if there's not a node nearby after chasing the player? So instead we'll just have him pivot on the spot and engage with the player that way. Okay, but what do we do if we finish the investigation, either spinning around in a circle to look for the player, and we're not able to find them? The thought is go back to patrol, right? Patrol, again, if you recall, will find a random node and send an enemy that way, just to start looking for the player again. But there's a problem with this. Well, because it tries and finds a random node, sometimes after chasing after the player, that random node is going to be behind the wall and therefore unreachable. So how do we fix this? I have these other two utility functions I've made: retrace steps and move to closest node. So after finishing investigating, and if it can't see the player anymore, it's going to retrace its steps, essentially go back to the position it was before he saw the player. And then after reaching that spot, he should be closer to a node, so that way he can move to the closest node after reaching that step. After he reaches the closest node, he's now back on the node-based system, so he can resume patrolling. Now, the player can of course be encountered through the retrace steps. While he's retracing the steps, sometimes if the player is found during that, we can switch to the engage pivot state, just like we did for the investigate state and chase state, just to start firing towards the player on the spot. Move to closest node is actually an interesting one. The transition, at least, instead of going to engage pivot, since we're already moving to a close by node, we can essentially just switch back to the engage as opposed to the engage pivot state. So even though we have two different engage states, they both can be used in their certain scenarios and have their own benefits. Now, there is still unfortunately an issue with the currently new states that we have integrated. A lot of them involve going off that node-based grid and back onto the node-based grid that we've set up. And this is a problem because sometimes the player will just enemy will just be constantly running into a wall as they're trying to get to one of the nodes, even though we've got this retrace steps stuff, and between chase, engage, pivot, all this stuff cannot save him from just running into walls certain times when he picks the wrong node. Sometimes the closest node is through a wall, and that becomes an issue. So how do I prevent this? Because the enemy keeps getting stuck on these sorts of obstacles, I've come up with an anti-stuck measure, which uses a timer to detect the amount of time an enemy stays in a state for. This is in particular for movement states, such as patrolling, chasing, retracing steps, and moving to the closest node. I set the timer to 7 seconds, and if the player is unsuccessful to getting them to their destination within the 7 seconds, they'll have the state switch to a different state. If they were currently in any of the movement states that wasn't moved to closest node, it's going to try and move to the closest node. If it did get stuck moving to the closest node, then instead it's going to switch to patrolling, which is kind of a way for it to find a random node to start patrolling once again. Although the focus for this project was to add more behaviors, I'd ideally like to make a couple of improvements in the future to this project so it becomes a better suit for a utility project. One of the things I want to do is get rid of the stuck timer. Instead of having a stuck timer that runs out to avoid enemies getting stuck, I want to have them stop getting stuck in the first place. Not the easiest fix, but definitely something I want to try and do. Getting the current state, I want to stop referring to the current state so often and instead have a more traditional object-oriented approach. Andrew showed off a pretty good example of it in the lecture, and I implore a similar thing to the Unity projects I've been working on this semester. Make use of the start, update, and exit functions. Currently, it has start and exit functions, but they use bool checks and they're not really encapsulated within the behavior itself, which kind of goes into my next point, encapsulating all the behaviors into the state itself, so that way it becomes a little bit less of a mess. And finally, adding some more transitions, whether they be transition states or maybe transition from one state to another, just to make it look a bit more clean between states. Another idea is to make a hierarchical finite state machine or a behavior tree, but those are sort of extra features. I'd rather just make improvements to the current existing system. So yeah, that's my extra behaviors and a couple improvements I'd like to make for the finite state machine. Thank you very much for watching.